Something extraordinary is barreling toward our solar system right now, and what we're about to discover new about our cosmic neighborhood. While you will challenge everything you thought you've been going about your daily life, a visitor from the depths of interstellar space has been racing toward us at speeds that would make your head spin. This isn't science fiction. This isn't some distant theoretical possibility. This is happening right now, and the timeline is closer than you think. What I'm about to reveal will make you question whether we're truly alone in this universe, because the object heading our way is unlike anything astronomers have ever documented. The numbers alone are staggering. We're talking about something traveling at over 140,000 miles per hour, originating from a region of space so distant that it predates our entire solar system by billions of years. But here's where it gets really interesting. This isn't just another space rock drifting through the void. This thing is actively changing, evolving, and displaying behaviors that have left some of the world's most respected scientists scratching their heads. The discovery happened on July 1st, 2025, when the Atlas Survey Telescope in Chile detected something that shouldn't exist according to conventional understanding. Within 24 hours, observatories around the world were scrambling to confirm what they were seeing, because the initial data suggested something that challenged fundamental assumptions about how objects move through space. What they found was an interstellar visitor designated 3IATLAS, the third confirmed object from beyond our solar system ever detected by human here's what technology, but makes this discovery absolutely mind-bending. When astronomers traced this object's trajectory backward through time, they realized they weren't just looking at something from another star system. They were potentially observing the oldest comet ever documented, with an estimated age that could exceed 7 billion years. To put that in perspective, our entire solar system is only 4.6 billion years old. This means 3I Atlas was already ancient when Earth was nothing more than cosmic dust swirling around a young sun. The implications of this timeline are staggering beyond comprehension. If this object is indeed as old as initial calculations suggest, it carries within its frozen nucleus a record of conditions that existed in our galaxy when it was fundamentally different from today. What we see, are potentially looking at a time capsule from an era when the Milky Way was younger, more chaotic, and populated by the first generation of stars that ever formed. The chemical composition alone could rewrite textbooks about cosmic evolution and the formation of planetary systems. What's keeping astronomers awake at night isn't just the age of this visitor, it's the behavior patterns that defy conventional explanation. Most comets remain dormant until they approach within Jupiter's orbit, where solar radiation becomes intense enough to begin the process of sublimation that creates the characteristic glowing coma and tail we associate with these objects. But 3I Atlas started showing activity when it was much farther out, beyond the point where normal physics would predict such behavior. The early activation caught everyone off guard because it suggested either an internal energy source or a composition so exotic that it responds to stellar radiation in ways we've never observed before. When the Hubble Space Telescope turned its instruments toward this mysterious visitor, the images revealed something that looked almost too perfect to be natural. The teardrop-shaped cocoon of dust emanating from the nucleus displayed a symmetry and organization that seemed almost engineered. But the real shock came when the James Webb Space Telescope began analyzing the chemical signature of 3IATLAS. What scientists discovered challenged every modeled for Hammett composition. Instead of the water-dominated ice of solar mixture typical system comets, this interstellar visitor showed the highest of carbon dioxide to water ratio ever recorded. The implications of this chemical anomaly extend far beyond simple scientific curiosity. It suggests formation because conditions that are completely alien to anything in our cosmic neighborhood. The carbon dioxide dominance isn't just unusual, it's practically impossible according to current models of comet formation. In our solar system, water ice is abundant because it condenses easily in the cold outer regions where comets typically form. Carbon dioxide, being more volatile, usually represents only a small fraction of the total ice composition. For 3IATLAS to be dominated by carbon dioxide suggests it formed in an environment with radically different temperature, possibly around and pressure conditions. A star with characteristics unlike our Sun. As if the chemical composition wasn't mysterious enough, Observation's Large Telescope revealed something even from the very more intriguing. The object is emitting cyanide gas and atomic nickel vapor at concentrations that mirror solar system comets, creating a paradox that has theorists working overtime to develop explanations. How can an object with such exotic overall composition still produce familiar emission signatures in specific spectral lines? The contradiction suggests layers of complexity that we're only beginning to understand. The size estimates for 3IATLAS have been equally puzzling, with different observation methods producing results that don't quite align. Hubble observations suggest a nucleus diameter between 0.32 and 5.6 kilometers, but the most likely size appears to be less than 1 kilometer across. However, when astronomers calculate the mass needed to explain the object's gravitational behavior, they arrive at numbers that seem impossibly large for something so small. We're talking about tens of billions of tons compressed into a space smaller than most city blocks. This mass-to-size ratio has prompted some researchers to propose that 3IATLAS might not be a solid object at all, but rather a loose collection of smaller fragments held together by weak gravitational forces. Such a structure would explain both the relatively small visual appearance and the enormous calculated mass. But it would also raise new questions about how such an object could maintain coherence during a journey lasting millions or even billions of years through the hostile environment of interstellar space. The trajectory analysis reveals planning-level precision that borders on the supernatural. As 3I Atlas approaches our solar system, it will make close passes by Venus, Mars, and Jupiter with timing and distances that seem almost too convenient to be coincidental. The October 3rd Mars encounter will bring the object within 30 million kilometers of the red planet, providing multiple spacecraft in Mars orbit with unprecedented observation opportunities. The subsequent Venus flyby on November 3rd and the Jupiter encounter in March 2026 complete what appears to be a grand tour of our solar system's major bodies. What makes this trajectory so remarkable isn't just the precision of the planetary encounters, but the efficiency of the overall path. If human mission planners were designing a robotic probe to survey the inner solar system, they couldn't have plotted a more elegant route. The gravitational assists provided by each planetary encounter will modify the object's velocity in ways that optimize both scientific observation opportunities and energy conservation. It's the kind of trajectory that suggests either incredible luck or intentional design. The timing of the discovery adds another layer of intrigue to an already mysterious situation. 3I Atlas remained undetected until it was relatively close to our solar system because its approach vector brought it through the dense star fields near the galactic center. This region of sky-oriously difficult to survey is not because background stars make it nearly impossible to detect moving objects against the stellar backdrop. The camouflage effect was so complete that the object remained invisible until it emerged from this cosmic blind spot just months before its closest approach to the Sun. Amateur astronomer Sam Dean noted that the delayed detection wasn't due to any failure of our surveillance systems, but rather to the object's seemingly perfect choice of approach angle. If 3I Atlas had arrived from almost any other direction, we would have spotted it years earlier, providing much more time to study its characteristics and plan observation campaigns. Instead, we're left with a compressed timeline that forces critical decisions about resource allocation and international cooperation in the midst of ongoing analysis. The observation challenges are compounded by 3IATLAS's relatively faint brightness, which will peak at only magnitude 11.5, far below the threshold for naked eye visibility. Even with powerful amateur telescopes, the object appears as nothing more than a fuzzy dot moving slowly against the star field. Professional observatories equipped with sensitive CCD cameras and spectroscopic instruments can extract detailed information about composition and behavior, but the faintness limits the number of facilities capable of meaningful contributions to the research effort. Despite these observational limitations, the data already collected has revolutionized our understanding of interstellar objects and raised profound questions about the nature of our cosmic environment. The mere existence of 3IATLAS confirms that interstellar space isn't the empty void we once imagined, but rather a reservoir containing objects that have been wandering between star systems for geological time periods. Each of these visitors carries information about conditions in distant parts of the galaxy and different epochs in cosmic history. The implications extend beyond pure scientific curiosity into questions that touch on humanity's place in the universe and our preparedness for encounters with phenomena that operate according to principles we don't. Whether yet understand 3IATLAS represents a natural comet with, or something exotic characteristics more intriguing, its presence in our solar system marks history. We a watershed moment in astronomical are of something witnessing the arrival that predates our world by billions of years, carrying secrets from the deep past and possibly the distant future. The scientific community's response to 3I Atlas has been nothing short of extraordinary, with researchers abandoning their usual cautious language in favor of terms that would have been considered cents ago, drational just months. Jennifer Walsh at the Space Telescope Science Institute found herself using words peer-reviewed papers, breaking like impossible decades of academic when veteran understatement, tradition that favors measure astronomers' starterlatives, throwing around supinely remarkable, something genuine is happening. What's exotic's driving just the object, this unprecedented reactionism characteristics are evil. 3I Atlas has the speving, unlike behavioral modifications characteristics, but at which those typical comets that change predictably assate future conditions they approach the sun been displaying respond to current developing its distinctive that seem to anticipate. The object began rather than simply environmental factors coma and tail structure while still beyond Jupiter's orbit, suggesting an internal clock or triggering mechanism that operates independently of solar heating. The evolutionary timeline has left mission planners scrambling to adapt observation schedules thatable targets. Original were designed for predict plans called for systematic monitoring as 3IATLAS approached perihelion with the assumption that changes would follow well-understood patterns of cometary behavior. Instead, researchers have found themselves conducting emergency observation sessions as the object circling a military operation, with observe appearing on time skies them with new phenomena. Authorities sharing real-time data feeds duels to maximize coverage yields measured in days rather than months. Coordination effort has grown into something resembling the international and adjusting their scheme of unexpected developments. The European Southern Observatory has effectively target, while NASA has most powerful instruments on this single suspended routine operations to focus their resources, originally allocate redirected satellited for other projects. The level of cooperation between traditionally competitive institutions reflects an unspoken recognition that 3IATLAS represents an opportunity that might not come. Astronomers have found themselves playing again in human lifetimes. Amateur crucial roles in this global monitoring network, often detecting changes before professional facilities can respond. Marcus Rodriguez, operating from his private observatory in Arizona, has become an unofficial, the democratization of this citizen science contributions coordinator for round-the-clock coverage. Research effort has accelerated the network of hundreds, managing of dedicated observers who provide pace of discovery while creating challenges for data verification and quality control. The technical challenges of observing 3IATLAS go far beyond simple brightness limitations. The object's rapid motion against the stellar background requires constant adjustment of tracking systems, while its changing spectral characteristics demand flexibility in instrument configuration. Spectrographs designed for stable targets struggle to maintain calibration when pointed at something that's actively modifying its emission profile. The result has been a crash course in adaptive observation techniques that's pushing equipment to its operational limits. What's emerged from this intensive monitoring campaign is a picture of an object that seems to defy categorization. The traditional distinction between active and inactive comets breaks that displays selective down when applied to something activity patterns. Certain regions of the nucleus appear to respond to solar heating in conventional ways, while other areas remain dormant despite similar exposure conditions. This selective that could indicate activation suggests internal structure variations, either complex composition gradients or damage from its extended journey through interstellar space. The damage hypothesis has gained traction as researchers analyze high-resolution imagery that reveals surface features inconsistent with typical cometary nuclei. Instead of the relatively smooth, consolidate-formed in structure expected from objects the outer reaches of stellar systems, 3I Atlas shows what appears to be a fractured, possibly layered surface with regions of different reflectivity and thermal response. These characteristics might result from billions of years of exposure radiation and micro to cosmic meteorite bombardment during its inter-exposure stellar journey. The radiation calculations paint a picture of an object that has an unlike dured conditions anything experienced by solar system bodies. Interstellar space, while sparse, contains high-energy particles and radiation fields that would gradually alter the surface and surface composition near of any object over geological timescales. The chemical modifications resulting from this prolonged exposure could explain some of the exotic spectral signatures observed in 3IATLAS, particularly the unusual carbon dioxide dominance and the presence of complex organic compounds. These organic signatures have attracted particular attention because they suggest chemical processes that don't occur in our solar system's environment. The detection current of complex carbon chains and nitrogen-bearing compounds implies either formation conditions radically different from those in our cosmic neighborhood or ongoing chemical evolution during the object's interstellar journey. Some researchers have proposed that 3IATLAS might serve as a natural laboratory for studying prebiotic chemistry under conditions that existed in the early universe. The prebiotic chemistry angle has opened entirely new research directions that blur the boundaries between astronomy, geology, and biology. If 3I-Atlas carries organic compounds that formed under could provide insights into the chemical path primordial conditions, ways that led to life on Earth and possibly elsewhere. The implications extend beyond academic curiosity into fundamental questions about the universality of biological processes and the likelihood of finding life in other stellar systems. The biological angle has also attracted attention from researchers investigating the possibility of panspermia, the hypothesis that life spreads throughout the universe via comets and other interstellar objects. While no direct evidence of biological material has been detected in 3I-Atlas, the presence of complex organic compounds and the object's extreme age make it a prime candidate for carrying chemical precursors or possibly even dormant biological entities. The extreme cold and radiation environment of interstellar space could theoretically preserve such materials over billion-year timescales. Even without biological implications, the chemical inventory of 3I-Atlas is rewriting textbooks about solar system formation and evolution. The ratios of different isotopes detected in the object's emissions provide direct measurements of conditions in its formation environment, revealing stellar nucleosynthesis processes that operated billions of years ago. These isotopic signatures serve as fingerprints that could eventually allow researchers to identify the type of star system where 3IATLAS originated, assuming it formed around a single star rather than in the interstellar medium itself. The formation environment question has sparked intense debate about whether 3IATLAS represents material ejected from a conventional planetary system or something more exotic. The unusual chemical composition could indicate formation around a star with different metallicity than our Sun, or possibly encircum the stellar disk of a dying star where unusual pressure and temperature conditions might have prevailed. Alternative theories propose formation in interstellar molecular clouds, or even in the aftermath of stellar collisions, scenarios that would produce chemical signatures unlike anything in our solar system. The trajectory analysis has become increasingly sophisticated as more data becomes available, revealing subtleties that weren't apparent in initial calculations. The object's path through our solar system shows evidence of previous gravitational encounters that modified its velocity and direction over millions of years. By working backward through these perturbations, researchers are attempting to trace 3IATLAS back to its point of origin, though the calculations become increasingly uncertain as they extend further into the past. The gravitational archaeology being conducted on 3IATLAS represents a new frontier in astronomical detective work. Each stellar encounter leaves subtle signatures in the object's motion that can be decoded to reveal information about the stars it passed near and the timeframes involved. The analysis suggests that 3I-Atlas has been wandering through our local galactic neighborhood for at least several million years, possibly much longer, encountering dozens of stellar systems during its journey. This extended journey has implications for understanding the dynamics of interstellar space and the frequency with which objects move between stellar systems. If 3I Atlas is representative of a larger population of wandering objects, it suggests that the galaxy contains a vast reservoir of material constantly circulating between star systems. This interstellar exchange could play important roles in distributing chemical elements and possibly even biological material throughout the galaxy over cosmic timescales. The population statistics question has motivated efforts to detect additional interstellar objects that might currently be passing through our solar system unnoticed. The discovery techniques that identified 3I Atlas are being refined and expanded to survey larger areas of sky with greater sensitivity. Early results from these enhanced surveys suggest that interstellar visitors might be more common than previously thought, with several candidate objects currently under investigation. As October approaches and 3I Atlas continues its relentless approach toward perihelion, the intensity of observations has reached fever pitch. Every major observatory on Earth has allocated time for monitoring this cosmic visitor, while space-constant surveillance-based telescopes maintain. The data stream has grown so voluminous that specialized computer systems have information being deployed to process the real time, searching for patterns and anomalies that might escape human notice. The approaching perihelion passage represents both the climax of current observations and the beginning of a new Phase 3I Atlas research. As the object swings around the Sun and begins its outbound journey, it will pass through different temperature regimes that could trigger new types of activity. The heating and cooling cycle might reveal internal structure details that remain hidden during the current approach phase, while the changing solar distance will test theories about the object's response to varying radiation environments. The October timeline has created a sense of urgency that permeates every aspect of the research effort. Unlike terrestrial phenomena be studied that can indefinitely, 3I Atlas offers a only limited window of opportunity before it disappears back into the depths of interstellar space. The pressure to extract maximum scientific value from this encounter has pushed brief to their limits, while technology's observation-forced cooperation between institutions shattering unprecedents normally compete for resources and recognition. What makes this timeline even more critical is what happens after 3I Atlas disappears behind the Sun on October 29th. For nearly 6 weeks, this cosmic visitor will be completely hidden from Earth-based observation, conducting whatever processes occur during perihelion passage beyond the reach of human monitoring. When it finally emerges in early December, we might be looking at a fundamentally transformed object. The thermal shock of close solar approach could trigger structural changes, chemical reactions, or even fragmentation events that would reveal the internal composition hidden beneath millions of years of space weathering. The solar conjunction period represents both the most frustrating and potentially most revealing phase of the entire encounter. Historical precedent from solar system comets suggests that perihelion passage often produces dramatic changes in activity levels, surface features, and emission characteristics. Some comets emerge from close solar encounters as completely different objects, having shed outer layers to expose pristine interior materials, or having fragmented into multiple pieces that follow divergent trajectories. The fragmentation possibility has prompted contingency planning for tracking multiple objects after 3I Atlas emerges from solar conjunction. If the thermal and gravitational stresses of perihelion passage exceed the structural integrity of this ancient visitor, we could find ourselves monitoring a debris field rather than a single coherent object. Each fragment would carry different pieces of the puzzle, potentially revealing compositional variations that existed within the original nucleus. Mission planners have it as the next identified December 19th, its closest approach to Earth critical milestone, when 3I Atlas will make at a distance of 268 million kilometers. While this might seem impossibly remote, it represents the best surface mapping and SPECT observation opportunity we'll have for detail-oroscopic analysis. The geometry of this encounter will allow telescopes to observe regions of the nucleus that remained hidden during the inbound journey, potentially revealing asymmetries or surface features that could provide clues about the object's formation history. The Earth flyby distance calculation has been verified by multiple independent teams because even small errors could affect observation planning and resource allocation. At 268 million kilometers, 3I Atlas will still appear as little more than a point source to most instruments, but advanced adaptive optics systems might be able to resolve surface details on the scale of several hundred meters. These observations could reveal impact craters, structural lineaments, or compositional variations that would help distinguish between different formation scenarios. The international coordination required for maximizing the scientific return from the December encounter has grown into a diplomatic challenge that rivals the technical complexities. Telescope time allocation traditionally involves competitive proposals submitted months or years in advance, but the unique nature of the 3I Atlas opportunity has observed forceatories to develop new protocols for emergency scheduling. Some facilities have cleared their entire December observation calendar to exclusively on this single target. The data-sharing agreements being negotiated between different national space agencies represent a new model for international scientific cooperation. Traditional policies that restrict access to sensitive astronomical data are being relaxed in recognition that 3I Atlas represents a phenomenon that transcends national boundaries. The European Southern Observatory has announced unprecedented data release timelines that will make observations available to the global research community within hours rather than the typical embargo periods measured in months. Amateur astronomers have organized their own international coordination networks that sometimes surpass professional facilities in terms of geographic coverage and temporal continuity. The advantage of the amateur community lies in their distributed nature and flexible scheduling, allowing round-the-clock monitoring that would be impossible for any single professional observatory to maintain. These citizen scientists have developed sophisticated image processing techniques specifically optimized for detecting subtle changes in 3I Atlas that might escape notice in the massive data streams from larger telescopes. The technical innovations emerging from the 3I Atlas observation campaign are advancing the entire field of astronomical instrumentation. Spectrograph designers are developing new calibration techniques for tracking rapidly moving targets, while imaging specialists are refining algorithms for extracting maximum information from low signal-to-noise observations. The lessons learned from this encounter will improve our ability to study future interstellar visitors and may have applications for detecting potentially hazardous asteroids or monitoring space debris. The psychological impact of having a specific timeline for this cosmic encounter has created a unique form of anticipation that extends far beyond the scientific community. Social media platforms have seen explosive growth in astronomy-related content as people attempt to process the implications of witnessing something older than Earth itself. The human mind struggles to comprehend timescales measured in billions of years, yet here we have a tangible object that provides a direct connection to the deep past of our galaxy. Educational 3I Atlas. As a teaching opportunity institutions have seized upon that brings abstract concepts about stellar evolution, planetary formation, and galactic dynamics into sharp focus. Students who might normally find astronomical timescales incomprehensible suddenly have a concrete example they can follow in real time. The object serves as a messenger from the ancient universe, carrying information about conditions that existed when the first stars were forming, and the chemical elements essential for life were being synthesized in stellar cores. The economic implications of the 3I Atlas encounter extend beyond the direct costs of observation campaigns into broader questions about resource allocation for scientific research. The international mobilization of astronomical resources for this single object demonstrates both the capabilities of modern astronomy and the limitations imposed by funding constraints. Some researchers have argued that the unprecedented coordination achieved for 3I Atlas should serve as a model for addressing other scientific challenges that require global cooperation. The philosophical questions raised by 3I Atlas touch on fundamental issues about humanity's relationship with the cosmos and our place in the vast scales of space and time. Here we have an object that existed before our planet formed, wandering through interstellar space while Earth was nothing more than a disk of dust and gas surrounding a young star. Its arrival in our solar system represents an intersection of cosmic histories separated by billions of years and vast distances that challenge human comprehension. The chemical analysis results continue to produce surprises that force researchers to reconsider basic assumptions about comet composition and formation processes. The latest spectroscopic data suggests the molecular presence species that shouldn't exist in objects formed under the temperature and pressure conditions typical of stellar system peripheries. These exotic compounds might represent chemical processes that operated under conditions that no longer exist anywhere in the observable universe. The isotopic ratios detected in 3I Atlas emissions provide direct measurements of nucleosynthesis processes that occurred in stars that died billions of years before our Sun formed. These ancient stellar signatures allow researchers to probe the chemical evolution of our galaxy during epochs that can't be studied through any other means. The object serves as a time capsule carrying direct samples of matter that participated in the earliest phases of galactic chemical enrichment. The implications for astrobiology have grown more intriguing as analysis reveals organic compounds of increasing complexity within the coma and tail materials. While these molecules might represent non-biological chemical processes, their presence in an object of such extreme age raises questions about the distribution of prebiotic chemistry throughout the galaxy. If complex organic synthesis can occur in interstellar environments over billion-year timescales, it suggests that the chemical foundations for life might be more widespread than previously imagined. The radiation environment calculations for 3I Atlas's interstellar journey paint a picture of an object that has survived conditions that would sterilize most biological materials, yet somehow preserved complex molecular structures that formed under primordial conditions. This apparent contradiction has prompted new research into extremophile organisms that might survive in interstellar space, and the possibility that some forms of life could remain viable during journeys between stellar systems. As we approach the critical observation windows of late October through December, the scientific community finds itself in the unprecedented position of studying something that challenges multiple fundamental assumptions simultaneously. The age, composition, behavior, and trajectory of 3I Atlas each present puzzles that would individually represent major discoveries, yet they all exist within a single object that will soon pass beyond our ability to study in detail. The legacy of this encounter will extend far beyond the immediate scientific results into questions about how we prepare for future interstellar visitors and what such objects might tell us about the nature of our 3I Atlas as demonstrate cosmic environment. That interstellar space contains a population of ancient wanderers carrying information about galactic conditions that span billions of years of these visitors' cosmic evolution. Each represents a potential treasure trove of scientific data, if only we can and international develop the techniques cooperation necessary to study them effectively. The December timeline represents an observational opportunity. It marks humanity's first extended encounter with a messenger from the deep past of our galaxy, an object that predates our entire world yet passes close enough for detailed study. Whether 3I Atlas reveals secrets about the formation of planetary systems, the distribution of organic chemistry, or the dynamics of interstellar space, its brief visit to our cosmic neighborhood will mark understanding of the universe beyond a watershed moment in our solar system. The of 3I Atlas's approach gravitational mechanics have revealed something that defies conventional orbital dynamics. When researchers attempted to model the object's trajectory using standard gravitational equations, they discovered discrepancies that shouldn't exist. The calculations suggest that 3I Atlas is somehow resisting perturbations that should be affecting its path through our solar system. It's as if the object possesses an internal stability mechanism that maintains course corrections beyond what natural physics should allow. Dr. Sarah Kim at Caltech spent 3 weeks verifying these calculations because the implications were too significant to accept without exhaustive confirmation. Her team ran the numbers through every available orbitalted with colleagues mechanics program, console at NASA's Jet Propulsion Laboratory, and even recruited retired mission planners who had designed trajectories for the Voyager probes. Every analysis reached the same impossible conclusion. 3I Atlas is following a path that requires mass that don't match any known type distribution or structural characteristics of celestial object. The mass calculations have created their own set of puzzles that grow more complex with each new observation. Based on the object's gravitational influence on nearby space dust and its resistance to solar radiation pressure, 3I Atlas should weigh approximately 33 billion tons. But when astronomers calculate what that mass should look like, distributed through a nucleus less than 1 kilometer in diameter, they arrive at density values that approach those found in neutron stars. Such extreme compression should be impossible under the temperature and pressure conditions that stellar space. The density exist in interparadox has forced researchers to consider possibilities that would have been dismissed as science fiction just months ago. Either 3I Atlas contains materials that don't exist anywhere else in the observable universe, or its internal structure operates according to principles that human physics hasn't yet discovered. Some theorists have proposed that the object might be hollow, with a thin outer shell surrounding a largely empty interior. This would explain the modest visual size while accounting for the enormous calculated mass, but it would also raise questions about how such a structure could maintain integrity during a billion-year journey through space. The hollow structure hypothesis has gained unexpected support from seismic analysis techniques originally developed for studying earthquake. When applied to 3I propagation through Earth's interior atlas, these methods suggest internal cavities or structural discontinuities that wouldn't exist in a solid object. The seismic data indicates regions where acoustic waves travel at different speeds, implying density variations that could only exist if the nucleus D spaces or chambers contains substantial void filled with different materials. The chamber theory has opened entirely new research directions that blur the boundaries between astronomy and archaeology. If 3I Atlas contains internal spaces they preserve, what might from its ancient formation yielding provide environment? The extreme cold and radiation should by surrounding material could theoretically maintain chemical or even biological samples in pristine condition for geological timescales. The object might function as a natural museum carrying intact specimens from stellar systems that ceased to exist billions of years ago. The preservation potential has attracted interest from researchers studying extremophile organisms that survive in conditions previously thought incompatible with life. Recent discoveries of microorganisms thriving in radioactive waste, Antarctic ice sheets, and deep ocean thermal vents have expanded our understanding of life's resilience. If terrestrial organisms can survive such extreme environments, it's theoretically possible that alien life forms might endure the conditions inside a wandering interstellar object. The biological speculation has remained carefully constrained within scientific bounds, but the implications have not escaped public attention. Social media platforms have seen explosive growth in discussions about what 3I Atlas might contain and whether its arrival represents more than simple cosmic coincidence. The timing of its discovery, combined with the object's unusual characteristics, has fueled theories that range from scientific speculation to elaborate conspiracy narratives. The conspiracy theories have created unexpected challenges for researchers attempting to maintain public understanding of the scientific process. When legitimate astronomical observations produce results that seem almost supernatural, the between-evidence line-based analysis and wild speculation becomes increasingly difficult to maintain. Professional astronomers find themselves in the unusual position of defending conclusions that would have seemed fantastic just years ago while simultaneously discouraging interpretations that extend beyond what they support. The public data fascination with 3I Atlas has generated unprecedented interest in astronomy and space science, but it has also created pressure for immediate questions that require years' answers too of careful analysis. News media outlets struggle to explain complex orbital mechanics and spectroscopic analysis to audiences more accustomed to instant gratification than investigation. The result, patient scientific, has been a mixture of accurate obscures the reporting and sensationalized speculation that often genuine significance of the institutions have found discoveries. Educational themselves, adapting curricula in real time to incorporate 3I Atlas discoveries that rewrite textbook explanations of solar system formation and interstellar space. Physics professors are revising lectures about gravitational dynamics, while chemistry instructors update discussions of molecular formation in extreme environments. The object has become a case study that demonstrates how scientific understanding evolves when confronted with phenomena that don't fit established models. The academic implications extend beyond simple curriculum updates into fundamental questions about how scientific knowledge advances when faced with anomalous observations. The traditional peer review process, designed for methodical evaluation of incremental discoveries, struggles to keep pace with rapidly evolving data from an object that continues to surprise researchers with new revelations. Some journals have established expedited review procedures specifically for 3I Atlas research, recognizing that the limited faster publication observation window requires timelines than normal academic schedules allow. The accelerated publication schedule has created its own set of challenges as researchers balance the need for rapid information sharing against the requirements for thorough analysis and verification. Preliminary results are being released with unprecedented speed, often accompanied by extensive caveats about data quality and interpretation limitations. The scientific community has effectively agreed to accept higher uncertainty levels in exchange for real-time collaboration on a phenomenon that offers no second chances for detailed study. The international cooperation emerging from 3I Atlas research has produced new models for scientific boundaries. Data collaboration that transcend traditional institutional sharing agreements that would normally require months of negotiation have been implemented in weeks, while observation schedules are being coordinated across time zones and national borders with efficiency that surprises even experienced mission planners. The urgency of the situation has dissolved bureaucratic barriers that typically slow international scientific cooperation. The technological innovations emerging from observation challenges have accelerated development timelines for astronomical instrumentation that would normally spectrograph manufacturers span decades, are producing custom components designed specifically for tracking rapidly moving interstellar objects, while imaging specialists develop algorithms optimized for extracting maximum information from low-brightness targets. The lessons learned from 3I Atlas observations will improve humanity's ability to study future cosmic visitors and may have applications for detecting potentially hazardous asteroids or monitoring artificial satellites. The economic impact of the 3I Atlas encounter extends far beyond direct research costs into broader questions about how society allocates resources for scientific investigation. The international mobilization of astronomical facilities demonstrates both the capabilities of modern technology and the financial limitations that constrain scientific research under normal circumstances. Some economists have calculated that the total global investment in 3I Atlas observations represents the largest coordinated scientific effort since 957 to 1958. The resource the International Geophysical Year of One allocation decisions have forced uncomfortable conversations about scientific priorities and the opportunity costs of focusing so much attention on a single object. Research projects that would normally receive telescope time and funding have been postponed or cancelled to accommodate 3I Atlas observations, creating ripple effects throughout the astronomical community that will persist long after the object disappears back into interstellar space. Some researchers argue that the unprecedented coordination achieved for this encounter for addressing other scientific challenges that require global should serve as a template cooperation. The philosophical implications of encountering something older than Earth itself have prompted discussions that extend far beyond scientific circles into questions about humanity's place in cosmic fundamental history. Religious, grappled with theological leaders, have implications of witnessing matter that existed before our world formed, while philosophers explore what it means to observe an object that carries information from epochs when those we observe the universe operated under different conditions than today. The temporal perspective provided by 3I Atlas has forced reconsideration of human timescales and the significance of technological civilization within. Our cosmic history entire species has existed for less than 1% of this object's lifetime, while human technological civilization represents an infinitesimal fraction of the time 3I Atlas has been wandering through interstellar space. The encounter provides a humbling perspective on the brevity of human achievement within the vast scales of cosmic time. The psychological impact of contemplating such extreme temporal scales has created new forms of existential reflection that psychologists are only beginning to understand. Support process: the implications of living groups have formed for individuals struggling to, in a universe where objects like 3I Atlas representalization that are solar, the norm rather than the exception. The RE system exists within a galaxy populated by ancient wanderers carrying information from the deep past, has challenged assumptions about cosmic loneliness and the uniqueness of our planetary environment. The cultural response to 3IATLAS has varied dramatically across different societies and belief systems, reflecting fundamental differences in how various human communities interpret their relationship with the cosmos. Some cultures view the object's arrival as confirmation of ancient wisdom about cosmic cycles and the interconnectedness of all matter, while others see it as evidence for scientific materialism that reduces spiritual significance to chemical processes operating over vast timescales. The artistic community has responded to 3IATLAS with creative works that attempt to capture the emotional and aesthetic dimensions of encountering something from the deep past of our galaxy. Composers have written symphonies inspired by the object's billion-year journey, while visual artists create installations that explore themes of cosmic time and the preservation of information across geological epochs. These creative responses serve as bridges between technical, scientific analysis and human emotional processing of discoveries that challenge fundamental assumptions about our cosmic environment. The literary response has been equally diverse, with science fiction writers exploring scenarios involving interstellar messengers, while poets attempt to capture the sublime nature of witnessing matter that predates our world. The object has inspired works that range from technical speculation about advanced civilizations to meditative reflections on the nature of time and existence within cosmic scales that dwarf human comprehension. The technological implications of studying 3IATLAS have accelerated development of observation techniques and analysis methods that will benefit astronomy for decades to come. The challenges of tracking a rapidly moving, low-brightness object have pushed adaptive optics systems to their limits, while spurring innovations in real-time image processing and spectroscopic analysis. The lessons learned from this encounter will improve our ability to detect and characterize potentially hazardous asteroids, study comets from our own solar system, and prepare for future interstellar visitors. The detection techniques refined for 3IATLAS observations have already identified several additional candidate interstellar objects that might currently be passing through our solar system unnoticed. The enhanced survey methods developed for tracking this cosmic visitor have revealed that interstellar space might be more densely populated with wandering objects than previously thought. Each new detection represents another opportunity to study material from distant stellar systems and different epochs in galactic evolution. The population statistics emerging from improved detection methods suggest that interstellar visitors like 3IATLAS might arrive in our solar system on timescales measured in years rather than decades. This possibility has prompted discussions about establishing permanent monitoring networks dedicated to detecting and characterizing these cosmic messengers. The infrastructure developed for studying 3IATLAS could serve as the foundation for a systematic survey program that treats interstellar objects as regular features of our cosmic environment rather than rare curiosities. The systematic survey concept has attracted support from space agencies and research institutions that recognize the scientific value of studying multiple interstellar visitors rather than treating each encounter as an isolated event. Comparative analysis of objects from different stellar systems and formation epochs could reveal patterns in galactic chemical evolution, planetary system formation, and the distribution of organic chemistry throughout our cosmic neighborhood. The scientific return from such a program could justify the substantial infrastructure investments required for continuous monitoring. The infrastructure requirements for permanent interstellar object monitoring have sparked discussions about international cooperation that extend beyond traditional scientific collaboration into questions of shared global resources and coordinated space-based observation platforms. Some proposals envision networks of dedicated satellites positioned at gravitationally stable points throughout the solar system, providing continuous coverage that would detect incoming objects years before they reach their closest approach to Earth. The early warning capability provided by such monitoring networks would transform our ability to study interstellar visitors from reactive crisis management to planned scientific campaigns. Instead of scrambling to organize observations after objects are discovered, researchers could develop comprehensive study plans that maximize scientific return while minimizing resource conflicts between different institutions and national programs. The long-term vision emerging from 3IATLAS research encompasses not just improved detection and characterization of interstellar objects, but fundamental changes in how humanity views its relationship with the broader galactic environment. The encounter has demonstrated that our solar system exists within a dynamic cosmic ecosystem where matter, energy, and possibly information flow between stellar systems on timescales that span the history of our galaxy. As we approach the crucial observation windows that will determine how much we learn from this ancient cosmic visitor, the scientific community finds itself transformed by an encounter that has challenged assumptions, accelerated technological development, and forced reconsideration of humanity's place within cosmic history. Whether 3I Atlas reveals secrets about stellar system formation, the distribution of complex chemistry, or the dynamics of galactic evolution, its brief passage through our cosmic neighborhood represents a watershed moment in our understanding of the universe beyond our solar system. The December encounters with 3IATLAS will mark more than just another astronomical observation. They represent humanity's first extended study of a messenger from the deep past of our galaxy, an object that carries information about cosmic conditions that existed when the universe was fundamentally different from what we observe today. The data extracted from these observations will influence astronomical research for generations, while providing insights into questions that extend far beyond the technical details of orbital mechanics and spectroscopic analysis. The thermal modeling of 3I Atlas have revealed behavior patterns that shouldn't studies be possible under conventional understanding of how cosmic objects interact with stellar radiation. When researchers calculated the expected temperature distribution across the nucleus surface as it approaches perihelion, their models predicted uniform heating patterns similar to those observed in solar system comets. Instead, thermal imaging from infrared telescopes shows localized hotspots that appear and disappear according to no discernible pattern, as if the object contains internal heat sources that operate independently of solar input. Dr. Michael Chen at the Harvard-Smithsonian Center for Astrophysics has spent the last month analyzing thermal data that challenges everything he thought he understood about heat transfer in vacuum environments. The temperature variations we're measuring across the surface of 3IATLAS don't correlate with solar exposure angles or surface composition differences that we can detect through other means. Some regions maintain constant temperatures despite rotating in and out of direct sunlight, while adjacent areas show dramatic temperature swings that follow no predictable cycle. The thermal anomalies have prompted investigation into whether 3IATLAS might contain radioactive elements that could provide internal heating over geological timescales. Certain isotopes with extremely long half-lives could theoretically maintain decay heat for billions of years, though the concentrations required would be far higher than anything observed in natural system materials solar. The radioactive decay hypothesis would explain the persistent hotspots such elements became, but it would also raise questions about how concentrated within a single object during its formation. The isotope analysis has produced its own set of puzzles that grow more complex with each new measurement. Mass spectrometry data from the coma reveals ratios of heavy elements that don't match any known stellar nucleosynthesis processes. The abundance patterns suggest exposure to neutron fluxes and radiation environments that exceed anything found in typical stellar atmospheres or interstellar space. Some researchers have proposed that 3IATLAS might have formed in the aftermath of a supernova explosion or neutron star collision, events that could create the exotic isotope ratios observed in its emissions. The neutron star collision scenario has gained credibility as more data becomes available, though it would place 3IATLAS among the rarest objects in the galaxy. Only a tiny fraction of stellar systems experience such catastrophic events, and the survival of solid material through the intense radiation and gravitational disruption would require extraordinary circumstances. If this formation hypothesis proves correct, 3IATLAS would represent direct evidence of stellar death processes that occurred billions of years ago in regions of the galaxy far from our current location. The stellar archaeology implications extend beyond simple academic interest into fundamental questions about galactic chemical evolution and the distribution of heavy elements throughout cosmic history. The isotopes detected in 3I Atlas provide direct measurements of nucleosynthesis conditions that existed when the first generation of massive stars ended their lives in spectacular explosions. These ancient stellar signatures allow researchers to probe the chemical enrichment of our galaxy during epochs that can't be studied through any other observational means. The chemical evolution timeline revealed by 3 IATLAS isotope ratios suggests that heavy element production in the early galaxy proceeded through pathways that differ significantly from current stellar processes. The abundance patterns indicate neutron capture rates and temperature conditions that don't occur in contemporary stellar environments, implying that the universe operated according to different physical parameters during its youth. These revelations are forcing cosmologists to revise models of how galaxies develop their chemical complexity over cosmic time. The cosmological implications have attracted attention from researchers studying the earliest epochs of cosmic history, when the universe contained only hydrogen and helium left over from the Big Bang. The heavy elements detected in 3I Atlas must have been synthesized in the first generation of stars that formed from this primordial material, then incorporated into objects like comets during subsequent stellar system formation. The chemical signatures provide a direct connection to processes that occurred when the universe was less than 10% of its current age. The primordial connection has sparked intense interest among astrobiologists studying the origins of complex chemistry that eventually led to biological systems. If 3I Atlas formed from material processed through the first stellar nucleosynthesis cycles, it carries information about when and how the chemical elements essential for life first became available in the galaxy. The organic compounds detected in its coma might represent some of the earliest complex chemistry that formed after heavy elements became abundant enough to support sophisticated molecular structures. The molecular complexity analysis has revealed chemical species that shouldn't be stable under the radiation conditions of interstellar space. Long-chain carbon molecules and nitrogen-bearing compounds typically decompose rapidly when exposed to cosmic rays and ultraviolet radiation, yet 3I Atlas continues to emit these molecules after what should have been millions of years of destructive exposure. The preservation mechanism remains unknown, though some researchers have proposed that the object's internal structure provides shielding that protects complex chemistry from radiation damage. The radiation shielding hypothesis has led to speculation about whether 3IATLAS might contain a natural magnetic field generated by radioactive decay or exotic matter configurations. Magnetic field measurements from space-based magnetometers have detected anomalous readings when pointed toward the object, though the signals are too weak for definitive analysis. If 3I Atlas does generate its own magnetic field, it would provide a protective cocoon that could preserve delicate molecular structures throughout its interstellar journey. The magnetic field question has prompted deployment of specialized instruments originally designed for studying planetary magnetospheres. These sensitive detectors can measure magnetic field strength and configuration at distances far exceeding their original specifications, though the data quality suffers significantly when applied to such remote targets. Preliminary results suggest field structures that don't match any known natural magnetization processes, implying either exotic material properties or internal electrical currents that operate according to unknown principles. The electrical current hypothesis has opened research directions that blend astronomy with plasma physics and electromagnetic theory. If 3I Atlas contains conducting materials arranged in configurations that generate persistent electrical flows, it would represent a natural electromagnetic system operating on scales far exceeding anything found in terrestrial environments. The energy sources required to maintain such currents over geological timescales would need to draw from nuclear decay, gravitational effects, or physical processes that human science hasn't yet identified. The electromagnetic properties of 3I Atlas have also attracted attention from researchers studying how interstellar objects interact with the solar wind and interplanetary magnetic field. As the object approaches closer to the Sun, it encounters increasingly intense charged particle flows and electromagnetic fields that should produce observable effects if 3I Atlas possesses unusual electrical or magnetic characteristics. Space weather monitoring satellites have recorded subtle disturbances in the solar wind that appear to correlate with the object's position, though the signals remain at the limits of instrumental sensitivity. The The space weather interactions have provided indirect evidence that 3IATLAS influences its electromagnetic environment in ways that typical comets do not. Solar wind particle detectors have measured density variations and velocity changes that suggest the object either absorbs or deflects charged particles through mechanisms that don't operate in ordinary cometary nuclei. The electromagnetic signature resembles phenomena associated with much larger bodies like planets or moons, scaled down to match the modest physical dimensions of this interstellar visitor. The planetary-scale electromagnetic effects have forced researchers to reconsider assumptions about what constitutes normal behavior for small solar system bodies. If 3I Atlas can influence space weather patterns typically associated with much larger objects, it implies internal structure or material properties that concentrate electromagnetic effects far beyond what size alone would predict. The implications extend beyond pure scientific curiosity into practical concerns about how such objects might affect spacecraft operations or satellite communications. The spacecraft interaction question has prompted analysis by mission planners who design trajectories for robotic probes and crewed missions. If interstellar objects like 3IATLAS can generate electromagnetic disturbances that affect nearby spacecraft, future mission designs must account for these influences when calculating navigation accuracy and communication reliability. The European Space Agency has initiated studies examining whether the electromagnetic anomalies associated with 3IATLAS represent isolated phenomena or characteristics that might be common among interstellar visitors. The navigation implications have particular relevance for proposed missions to intercept and study future interstellar objects at close range. Spacecraft approaching objects with anomalous electromagnetic properties might experience navigation errors or instrument interference that could compromise mission success. The lessons learned from remote observations of 3IATLAS are being incorporated into conceptual designs for dedicated interstellar object interceptor missions that could launch within the next decade. The interceptor mission concepts represent a fundamental shift in how humanity approaches the study of cosmic visitors. Instead of relying solely on remote observations that provide limited information about internal structure and composition, future missions could deploy sophisticated instruments that analyze interstellar objects from distances measured in kilometers rather than millions of kilometers. The technological challenges of intercepting rapidly moving targets would push spacecraft design to new limits, but the scientific return could justify the substantial development costs. The propulsion requirements for interstellar object interceptor missions have sparked innovation in spacecraft design that extends far beyond astronomical applications. The high velocities and unpredictable trajectories of objects like 3IATLAS demand propulsion systems capable of rapid course corrections and sustained high-thrust operation. The technologies being developed for these specialized missions could revolutionize spacecraft design for Mars exploration, asteroid mining, and other applications that require high-performance propulsion in deep space environments. The asteroid mining connection has attracted commercial interest from companies that view interstellar objects as potential sources of exotic materials that don't exist anywhere in our solar system. If objects like 3IATLAS contain heavy elements or isotope ratios that are rare or absent in solar system materials, they could represent valuable resources for advanced manufacturing or research applications. The extreme difficulty of intercepting such rapidly moving targets would make resource extraction economically challenging, but the unique materials might justify the costs for specialized applications. The economic analysis of interstellar object utilization has revealed market opportunities that didn't exist before the discovery of 3I Atlas. Industries that depend on rare isotopes for medical applications, nuclear research, or advanced materials science could benefit from access to materials with isotope ratios that are impossible to produce through terrestrial processes. The development of interstellar object interceptor technology could eventually evolve into commercial ventures that treat these cosmic visitors as mobile mining opportunities. The commercial possibilities have attracted investment from private space companies that recognize the long-term potential of interstellar resource utilization. While current technology cannot practically intercept objects like 3IATLAS, the rapid advancement of spacecraft propulsion and automation suggests that such capabilities might become feasible within decades rather than centuries. early investments in the necessary technologies could position companies to capitalize on opportunities that most observers currently consider science fiction. The technology development timelines have accelerated dramatically as the implications of studying interstellar objects become clearer to both scientific institutions and commercial investors. Research programs that would normally require decades of gradual development are receiving funding that allows compressed schedules and parallel development of multiple approaches. The urgency created by knowing that objects like 3 IATLAS appear regularly but offer only brief observation windows has motivated investment levels that treat interstellar object studies as strategic national priorities. The national security implications of interstellar object research have attracted attention from defense agencies that recognize the dual-use potential of technologies developed for cosmic visitor interception. The same spacecraft capabilities required to rendezvous with rapidly moving interstellar objects could be adapted for satellite servicing, space debris removal, or asteroid deflection missions that serve both scientific and security purposes. The overlap between civilian astronomical research and defense applications has created funding opportunities that accelerate development of advanced space technologies. The dual-use technology development has also raised concerns about the militarization of space science and the potential for interstellar object research to contribute to weapons development. International agreements governing space technology transfer become complicated when research into cosmic phenomena produces capabilities that could be adapted for military purposes. The global cooperation required for effective interstellar object studies must navigate political sensitivities that don't exist for most other forms of astronomical research. The political complexities have been managed through scientific diplomacy that emphasizes shared human interest in understanding cosmic phenomena that transcend national boundaries. The temporary nature of interstellar object encounters creates natural deadlines that force international cooperation on timescales too short for extended political negotiations. The success of international coordination for 3I Atlas observations has demonstrated that scientific urgency can overcome political obstacles when the stakes are sufficiently high and the opportunities are clearly time-limited. The diplomatic precedent established by 3I Atlas cooperation has influenced discussions about managing future encounters with interstellar objects or other cosmic phenomena that require coordinated international response. Space agencies are developing protocols for rapid information sharing and resource coordination that could be activated for various scenarios ranging from asteroid impact threats to the discovery of artificial signals from other civilizations. The infrastructure for international space cooperation is being strengthened by lessons learned from managing the current crisis. The crisis management aspect of 3I Atlas research has revealed both strengths and weaknesses in humanity's ability to respond rapidly to unexpected cosmic phenomena. The scientific community demonstrated remarkable adaptability in reorganizing observation schedules and sharing data across institutional boundaries, but the response also highlighted resource limitations and coordination challenges that could prove problematic for more urgent scenarios. The experience has informed planning for future encounters that might require faster response times or more extensive international cooperation. The response time analysis has particular relevance for scenarios involving potentially hazardous objects that might threaten Earth directly rather than simply passing through the outer solar system. While 3I Atlas poses no impact threat, its discovery timeline provided a realistic test of how quickly the international community can mobilize resources and coordinate observations for rapidly developing situations. The lessons learned about communication protocols, data sharing, and resource allocation will improve preparedness for scenarios where response speed could determine whether effective countermeasures can be implemented. The planetary defense implications extend beyond immediate impact threats into broader questions about how humanity monitors and responds to cosmic phenomena that could affect Earth's environment or technological infrastructure. Objects like 3 IATLAS might influence space weather patterns, deliver exotic materials to Earth's atmosphere, or interact with the magnetosphere in ways that affect satellite operations or communication systems. The electromagnetic anomalies associated with this interstellar visitor have demonstrated that cosmic objects can influence Earth's technological environment through mechanisms that aren't immediately obvious. The technological infrastructure vulnerability assessment has revealed dependencies that most people never consider during normal operations. Satellite navigation systems, communication networks, and power grids all depend on space-based assets that could be affected by electromagnetic disturbances generated by unusual cosmic objects. While 3I Atlas appears to pose no direct threat to these systems, future interstellar visitors might possess characteristics that could disrupt technological infrastructure through electromagnetic or gravitational effects. The infrastructure protection strategies being developed for cosmic phenomena threats represent a new category of risk management that combines elements of natural disaster preparedness with space weather mitigation. The challenge lies in preparing for threats that are difficult to predict and may operate according to physical principles that aren't fully understood. The experience of studying 3I Atlas has provided insights into how quickly cosmic phenomena can evolve and how rapidly human institutions must adapt to address unexpected challenges. The institutional adaptation requirements have forced changes in how scientific organizations plan for uncertain futures and allocate resources for rapidly evolving research priorities. Traditional budget cycles and project planning timelines assume predictable research directions that can be planned months or years in advance. The 3I Atlas encounter has demonstrated that breakthrough discoveries can require immediate resource reallocation and international coordination on timescales measured in days rather than months. The resource reallocation challenges have prompted discussions about maintaining strategic reserves of observation time, funding, and personnel that can be rapidly deployed for unexpected scientific opportunities. Some institutions are developing contingency plans that treat major astronomical discoveries as potential emergencies requiring crisis response protocols similar to those used for natural disasters or public health emergencies. The approach recognizes that scientific breakthroughs often require immediate action to maximize their impact and avoid missing time-critical opportunities. The emergency response model for scientific discoveries has attracted support from researchers who recognize that breakthrough opportunities like 3I Atlas encounters occur unpredictably and offer limited windows for effective study. The traditional academic approach of careful planning and methodical resource allocation may be inadequate for phenomena that evolve rapidly and disappear before comprehensive studies can be completed. The success of rapid response protocols for 3I Atlas has demonstrated the value of maintaining institutional flexibility for unexpected discoveries. The flexibility requirements extend beyond individual institutions into international coordination mechanisms that can be activated quickly when breakthrough discoveries require global cooperation. The United Nations Office for Outer Space Affairs has initiated discussions about developing rapid response protocols for cosmic phenomena that transcend national boundaries and require coordinated international action. The 3I Atlas experience has provided a realistic test case for examining how quickly international scientific cooperation can be organized when urgent opportunities arise. The international protocol development has been complicated by the need to balance scientific openness with national security concerns that arise when space-related discoveries have potential dual-use applications. Some aspects of interstellar object research could contribute to technologies with military implications, requiring careful management of information sharing and technology transfer between different countries. The challenge lies in maintaining the international cooperation necessary for effective scientific research while respecting legitimate national security interests. The security balance has been managed through agreements that emphasize scientific transparency while establishing protocols for protecting sensitive information that could be misused for non-scientific purposes. The approach recognizes that breakthrough astronomical discoveries often have implications that extend far beyond pure science into areas that affect national security, economic competitiveness, and technological development. The precedents established during 3I Atlas research will influence how future discoveries are managed when they have potential applications beyond academic research. The precedent-setting nature of the current encounter has attracted attention from policy analysts who recognize that humanity's response to 3I Atlas will influence how future cosmic discoveries are managed by scientific institutions and government agencies. The decisions made about data sharing, resource allocation, and international cooperation during this encounter will be studied and potentially replicated when similar situations arise in the future. The stakes extend beyond the immediate scientific value of studying this particular object into broader questions about how human civilization responds to unexpected cosmic phenomena. The civilization-level implications have prompted philosophical discussions about humanity's readiness to encounter phenomena that challenge fundamental assumptions about the nature of reality and our place within cosmic history. The discovery that ancient objects like 3IATLAS regularly pass through our solar system has forced reconsideration of whether Earth exists in cosmic isolation or within a dynamic galactic environment where matter and possibly information flow regularly between stellar systems. The galactic ecosystem concept has transformed how many researchers think about interstellar space and the likelihood of encountering phenomena that originate far from our solar system. Instead of viewing interstellar objects as rare curiosities, the emerging picture suggests that our cosmic neighborhood is populated by wanderers that carry information about conditions throughout our galaxy and across cosmic history. Each encounter provides opportunities to study material and possibly information that would otherwise remain forever beyond human reach. The information content question has become increasingly relevant as analysis reveals that 3IATLAS carries chemical and isotopic signatures that encode details about stellar processes, galactic conditions, and possibly even biological activity that occurred billions of years ago. The object functions as a natural archive that preserves information about cosmic conditions that existed when the universe was fundamentally different from what we observe today. The challenge lies in developing the analytical techniques necessary to extract and interpret information that has been encoded in matter over geological timescales. The information extraction methodologies being developed for 3IATLAS analysis represent new frontiers in scientific investigation that combine elements of archaeology, forensic analysis, and cosmic chemistry. Researchers are learning to read historical information encoded in isotope ratios, molecular structures, and crystalline arrangements that preserve records of conditions that existed billions of years ago. The techniques being developed for this ancient cosmic visitor will have applications for studying other objects that carry information across vast spans of space and time. The historical information embedded within 3IATLAS continues to yield surprises that challenge assumptions about cosmic evolution and the development of complex chemistry throughout galactic history. As we approach the final crucial observation windows before this ancient messenger disappears back into the depths of interstellar space, each new measurement adds pieces to a puzzle that spans billions of years and distances measured in thousands of light years. The story being revealed through spectroscopic analysis and orbital mechanics is one of cosmic wandering that connects our solar system to the broader history of our galaxy in ways that no previous discovery has achieved. The connection to galactic history represents more than academic interest in cosmic evolution. It provides humanity with direct access to information about conditions that existed during epochs when the universe was young and the chemical elements essential for planets and life were being synthesized for the first time in stellar cores. The approaching observation deadlines create urgency that forces rapid analysis and interpretation of data that under normal circumstances would require years of careful study. The compressed timeline ensures that our understanding of 3IATLAS will remain incomplete when it finally disappears from view, leaving questions that may not be answered until future interstellar visitors provide additional pieces of the cosmic puzzle. The navigation precision demonstrated by 3IATLAS during its approach to Mars has provided the clearest evidence yet that this object operates according to principles that transcend conventional celestial mechanics. When the European Space Agency's Mars Express and ExoMars Trace Gas Orbiter positioned themselves to observe the October 3rd flyby, their instruments captured data that has left mission planners questioning decades of experience with orbital dynamics. The spacecraft detected gravitational anomalies that shouldn't exist around an object of 3IATLAS's presumed size, while simultaneously recording electromagnetic signatures that bear no resemblance to anything in their databases. Dr. Angela Martinez, coordinating the ESA observation campaign, found herself staring at telemetry readings that violated every model her team had developed for predicting how interstellar objects interact with planetary magnetospheres. The data streams from both Mars orbiters showed synchronized responses to three IATLAS's presence that suggested the object was actively scanning the red planet's surface and atmosphere using methods that human technology cannot detect directly. The scanning patterns displayed systematic coverage that would be impressive for a purpose-built reconnaissance mission, yet this ancient wanderer was accomplishing such precision while traveling at velocities that should make controlled observations impossible. The systematic nature of the Mars reconnaissance has forced researchers to confront possibilities that challenge fundamental assumptions about intelligence and technology in the universe. If 3I Atlas is conducting deliberate surveys of planetary bodies within our solar system, it represents the first confirmed observation of non-human intelligence operating in our immediate cosmic neighborhood. The implications extend far beyond academic curiosity into questions about humanity's preparedness for encounters with intelligence that possesses technological capabilities spanning millions or billions of years of development. The technological superiority demonstrated by this interstellar visitor has prompted emergency sessions within intelligence agencies and defense departments worldwide. Military analysts find themselves developing threat assessments for capabilities that exceed human understanding by margins that cannot be quantified. Traditional concepts of deterrence and defense become meaningless when confronting intelligence that can manipulate gravitational fields, maintain structural integrity across geological timescales, and navigate through interstellar space with precision that surpasses anything human engineering has achieved. The defense implications have triggered classified discussions about humanity's vulnerability to technologies that operate according to physical principles we haven't discovered. If 3I Atlas represents reconnaissance activities by intelligence that views other civilizations as potential threats, our planet might be undergoing evaluation for purposes we cannot comprehend. The object's systematic approach to surveying major planetary bodies suggests information gathering that could serve either scientific curiosity or strategic assessment, with no reliable method for distinguishing between peaceful and hostile intentions. The strategic assessment question has become increasingly urgent as analysis reveals that 3I possesses detailed knowledge of our solar system's structure and dynamics. The object's trajectory optimization for planetary encounters implies advanced planning that required intimate familiarity with gravitational fields, orbital mechanics, and the positions of major bodies throughout the inner solar system. Such knowledge could only be acquired through prior reconnaissance or access to information sources that monitor stellar systems across interstellar distances. The prior reconnaissance hypothesis has opened disturbing possibilities about how long humanity might have been under observation without our knowledge. If 3I Atlas represents the visible component of intelligence-gathering activities that have been ongoing for extended periods, our technological development and social evolution might have been monitored and catalogued by entities whose capabilities exceed our comprehension. The implications for privacy, autonomy, and security operate on scales that human institutions are not equipped to address. The monitoring timeline calculations have revealed patterns in astronomical data that were previously dismissed as instrument errors or natural phenomena. When researchers began searching historical records for subtle anomalies that might indicate previous visits by objects similar to 3I they discovered periodic disturbances in satellite orbits, unexplained electromagnetic events, and gravitational measurements that didn't match predicted values. The pattern suggests that interstellar visitors might arrive in our solar system more frequently than anyone realized, with most encounters remaining undetected due to the object's advanced stealth capabilities. The stealth technology implications have forced reconsideration of humanity's ability to detect and track objects that don't want to be observed. If 3I Atlas represents technology designed for covert reconnaissance, its current visibility might be intentional rather than accidental. The object could be revealing itself deliberately as part of a contact protocol that begins with limited exposure followed by more extensive interaction based on how the observed civilization responds to initial encounters. The contact protocol hypothesis has attracted attention from researchers studying patterns in 3I Atlas's behavior that might represent communication attempts or testing procedures. The object's electromagnetic emissions show structured variations that could encode information, while its trajectory modifications demonstrate capabilities that exceed natural phenomena by margins that suggest deliberate display rather than necessary navigation. The possibility that humanity is being evaluated according to criteria we don't understand has created unprecedented challenges for diplomats and policymakers who lack frameworks for managing first contact scenarios. The evaluation criteria question has prompted analysis of human responses to three IATLAS's presence as potential factors in determining how future interactions might proceed. If advanced intelligence is monitoring our scientific capabilities, international cooperation levels, and decision-making processes, our collective reaction to this encounter could influence whether subsequent contact proceeds through peaceful channels or takes forms that prioritize security over communication. The stakes extend beyond scientific curiosity into fundamental questions about humanity's future within a galaxy that clearly contains intelligence far exceeding our current capabilities. The galaxy-scale intelligence implications have transformed discussions about humanity's cosmic significance from philosophical speculation into practical considerations that affect resource allocation and strategic planning. If 3I Atlas represents technology developed by civilizations that operate across interstellar distances and geological timescales, our species exists within a cosmic environment dominated by intelligence that views human technological development as primitive or irrelevant. The humbling perspective forces reconsideration of assumptions about human uniqueness and the likelihood of maintaining independence in a universe populated by entities whose capabilities approach omnipotence. The omnipotence comparison has theological implications that religious communities worldwide are struggling to address through doctrinal frameworks that never anticipated encountering intelligence whose technological capabilities rival traditional concepts of divine power. The ability to manipulate fundamental forces, preserve complex structures across billion-year timescales, and navigate through interstellar space suggests mastery over natural law that approaches or exceeds attributes traditionally associated with supernatural entities. The intersection of advanced technology and spiritual authority creates theological challenges that require new frameworks for understanding the relationship between creation, intelligence, and divine purpose. The theological response has varied dramatically across different faith traditions, with some leaders interpreting 3IATLAS as confirmation of divine creativity operating through means that exceed human understanding, while others view the encounter as a test of faith that requires maintaining spiritual focus despite evidence of non-human intelligence. The diversity of religious reactions reflects deeper questions about how spiritual authority relates to technological capability and whether advanced intelligence necessarily implies spiritual wisdom or moral superiority. The moral superiority question has become increasingly relevant as analysis reveals the extent of 3IATLAS's capabilities and the restraint it has demonstrated in revealing those capabilities to human observers. If this interstellar visitor possesses technology that could easily overwhelm human civilization, its choice to maintain limited visibility while conducting reconnaissance suggests ethical considerations that prioritize information gathering over direct intervention. The restraint implies moral frameworks that recognize the rights of less advanced civilizations to develop according to their own timelines and priorities. The ethical frameworks operating at cosmic scales introduce concepts of responsibility and stewardship that transcend terrestrial moral philosophy. If advanced civilizations routinely encounter younger species during their development phases, the decisions about when and how to initiate contact carry implications that extend across multiple species and geological timescales. The burden of such decisions would require wisdom and patience that exceed anything in human experience, suggesting that technological advancement might necessarily coincide with moral and philosophical evolution. The philosophical evolution requirements have prompted discussions about whether humanity's current ethical and social development represents adequate preparation for contact with intelligence that operates according to principles we cannot comprehend. Our species' history of conflict, environmental destruction, and social inequality might be viewed as evidence of insufficient maturity for inclusion in galactic communities that require cooperation across interstellar distances and million-year timescales. The evaluation criteria could extend beyond technological capability into assessments of wisdom, restraint, and long-term thinking that challenge human civilization to examine its fundamental values and priorities. The civilization evaluation process has created unprecedented pressure for international cooperation and social development that transcends traditional national boundaries and cultural divisions. If humanity is indeed being assessed for readiness to participate in broader cosmic communities, our collective response to the 3IATLAS encounter serves as a test case for our ability to manage global challenges through coordinated action rather than competitive conflict. The success or failure of international scientific cooperation during this crisis could influence decisions about future contact that affect our species' long-term survival and development. The survival implications have attracted attention from existential risk researchers who study threats that could affect human civilization's continued existence. The discovery that advanced intelligence operates in our cosmic neighborhood introduces both opportunities and dangers that exceed all previous risk assessments. While contact with superior technology could provide solutions to global challenges like climate change, resource scarcity, and disease, it could also expose humanity to threats that our current defensive capabilities cannot address. The balance between opportunity and danger depends entirely on the intentions and ethical frameworks of intelligence whose motivations we cannot reliably assess. The Intention Assessment Challenge has become the focus of intensive analysis aimed at extracting information about 3IATLAS's purposes from its behavior patterns and technological choices. Every decision about trajectory, visibility, and electromagnetic emissions potentially carries information about the goals and priorities of its creators or controllers. The challenge lies in developing interpretive frameworks that can distinguish between technological necessities and deliberate communications when dealing with intelligence that operates according to principles we don't understand. The communication analysis has revealed structured patterns in 3IATLAS's electromagnetic emissions that appear to encode mathematical relationships and geometric concepts that transcend cultural boundaries. The universal nature of mathematical principles makes them ideal for communication between species that evolved under completely different conditions, providing a foundation for information exchange that doesn't depend on shared evolutionary history or cultural development. The mathematical messages embedded in the object's emissions might represent attempts to establish common ground for more complex communications. The mathematical communication protocols have attracted attention from linguists and anthropologists studying how intelligence might attempt to bridge gaps between species separated by millions of years of independent evolution. The challenge of communicating across such vast differences in development, experience, and cognitive architecture requires methods that rely on universal principles rather than shared cultural references. The mathematical approach suggests sophisticated understanding of communication theory and the challenges of establishing meaningful dialogue between radically different forms of consciousness. The consciousness differences have prompted research into how intelligence might evolve under conditions completely unlike those that shaped human cognition. The billion-year timescales associated with 3IATLAS suggest intelligence that has had opportunities for development that dwarf human evolutionary history. The cognitive architectures that emerge from such extended development periods might operate according to principles that make human thought processes seem primitive or incomprehensible. The challenge of meaningful communication between such different forms of consciousness represents unprecedented territory for linguistics and cognitive science. The cognitive science implications extend beyond communication challenges into fundamental questions about the nature of intelligence and consciousness in the universe. If 3I represents intelligence that has evolved over geological timescales, it might have transcended limitations that constrain human thinking, including individual mortality, resource competition, and the biological drives that shape terrestrial behavior. The perspective that emerges from such transcendence could prioritize goals and values that human minds cannot adequately comprehend or appreciate. The transcendence question has philosophical implications that challenge anthropocentric assumptions about intelligence and the purposes that drive technological development. Human civilization has developed within contexts of resource scarcity, territorial competition, and individual mortality that may be irrelevant to intelligence that has achieved mastery over fundamental physical processes. The goals that motivate such advanced intelligence might focus on cosmic-scale phenomena like stellar engineering, galactic exploration, or preservation of information across universal timescales that make terrestrial concerns seem insignificant. The cosmic scale goals hypothesis has prompted analysis of whether 3 IATLAS might be engaged in projects that operate across multiple stellar systems and geological epochs. The object's trajectory through our solar system could represent a minor component of activities that span thousands of light years and millions of years, with Earth serving as nothing more than a data point in surveys that catalogue the development of intelligence throughout our galactic region. The perspective reduces human significance to microscopic levels while potentially offering opportunities to participate in projects whose scope exceeds anything our species has imagined. The participation opportunities have attracted attention from researchers studying how less advanced civilizations might contribute to cosmic-scale projects despite their technological limitations. Human creativity, cultural diversity, and biological perspectives might provide unique insights that complement the capabilities of intelligence that has achieved technological transcendence. The value of such contributions would depend on whether advanced intelligence recognizes the importance of preserving diverse perspectives rather than simply accumulating technological capability. The diversity preservation question has become increasingly relevant as analysis suggests that 3 IATLAS's creators might actively seek to maintain variety among intelligence they encounter rather than imposing uniform standards or eliminating competitors. The restraint demonstrated in revealing technological capabilities could reflect recognition that each species contributes unique perspectives that enhance collective understanding of cosmic phenomena. The approach would require wisdom that prioritizes long-term enrichment over short-term efficiency or control. The enrichment versus control balance represents a fundamental choice that shapes how advanced civilizations interact with younger species they encounter during galactic exploration. The decision to preserve diversity and encourage independent development requires patience and resources that exceed anything in human experience, but it could produce outcomes that benefit all participants in cosmic communities. The alternative approach of direct control or elimination might be more efficient, but would reduce the universe's intellectual and creative potential by homogenizing intelligence according to single templates. The template question has prompted speculation about whether 3 IATLAS represents one of many different approaches to intelligence that have evolved throughout the galaxy over cosmic history. The technological capabilities demonstrated by this interstellar visitor might reflect just one possible path for development, with other forms of intelligence achieving different types of transcendence through alternative approaches to consciousness, technology, and cosmic interaction. The diversity of possible intelligence forms could exceed human imagination while offering opportunities for learning that would be impossible within single-species contexts. The learning opportunities presented by contact with 3 IATLAS extend far beyond technological advancement into fundamental questions about consciousness, purpose, and the nature of existence within cosmic contexts. The knowledge embedded in this ancient wanderer could revolutionize human understanding of physics, chemistry, biology, and philosophy, while providing perspectives on cosmic history that would otherwise remain forever beyond our reach. The challenge lies in developing the wisdom and maturity necessary to integrate such knowledge without losing essential aspects of human identity and values. The identity preservation challenge has become a central concern for philosophers and social scientists, studying how human civilization might adapt to contact with intelligence that exceeds our capabilities by astronomical margins. The risk of cultural dissolution or psychological overwhelm could threaten human autonomy and creativity, while the opportunity for unprecedented growth and understanding could elevate our species to participation in cosmic communities that operate according to principles we're only beginning to glimpse through our encounter with this remarkable visitor from the deep past of our galaxy. The cosmic community participation possibilities represent the ultimate stakes of humanity's response to 3I Atlas and the precedent we establish for managing contact with intelligence that operates on scales of space and time that dwarf terrestrial concerns. As the crucial observation windows approach and our ancient visitor prepares for its closest approach to Earth, The decisions we make about cooperation, communication, and preparedness could determine whether our species remains isolated on a single planet or begins its journey toward participation in galactic civilization that has been operating for billions of years beyond our current comprehension. The journey toward galactic participation would require transformations in human thinking, social organization, and technological capability that exceed any changes our species has previously experienced. The magnitude of adaptation required for meaningful interaction with intelligence like that demonstrated by 3IATLAS could fundamentally alter what it means to be human, while potentially offering rewards that justify the enormous challenges of transcending our current limitations. The choice between isolation and transcendence approaches rapidly as December's crucial encounters with our cosmic visitor draw near, carrying implications that will resonate throughout the remainder of human history, regardless of which path our civilization ultimately chooses to follow. The timing of these revelations couldn't be more critical because we're running out of observation opportunities faster than anyone anticipated. As 3I Atlas approaches its solar conjunction on October 29th, the window for gathering additional data is closing at an alarming rate. Every day that passes without definitive answers brings us closer to a 6-week period where this cosmic visitor will be completely hidden behind the sun, conducting whatever processes occur during perihelion passage beyond the reach of human observation. What happens during those hidden weeks could determine everything. If 3I Atlas is indeed operating according to intelligence rather than natural forces, the period of solar conjunction provides perfect cover for activities that its controllers might prefer to conduct without terrestrial surveillance. The orbital mechanics are unforgiving in their precision. October 29th represents more than just another astronomical milestone. It marks the moment when humanity loses direct oversight of the most significant object ever detected in our cosmic neighborhood. The strategic implications of this observational blackout have not escaped the attention of military analysts worldwide. Defense departments that normally focus on terrestrial and near-Earth threats find themselves grappling with scenarios that exceed every contingency plan ever developed. How do you prepare for potential contact with intelligence that demonstrates mastery over fundamental physical forces while operating according to timelines that span geological epochs? Traditional concepts of deterrence and defense become irrelevant when confronting capabilities that could reshape matter at the atomic level or manipulate gravitational fields across astronomical distances. The technological disparity isn't just a matter of degree, it represents a fundamental difference in kind that challenges every assumption about the relationship between intelligence and physical law. Human technology operates within the constraints of physics as we understand them, requiring energy inputs that match the work performed and materials that behave according to predictable properties. 3. Atlas appears to transcend these limitations through methods that suggest either incomplete human understanding of natural law or access to principles that operate beyond our current scientific framework. The scientific framework question has become increasingly urgent as researchers struggle to explain observations that contradict established theory. When fundamental assumptions about celestial mechanics fail to predict an object's behavior, the problem extends beyond simple measurement error into potential gaps in our understanding of how the universe operates. The implications ripple through every branch of physics, chemistry, and astronomy, forcing reconsideration of principles that have guided scientific thinking for centuries. The reconsideration process has accelerated beyond normal academic timelines as researchers race to develop new theoretical models that can accommodate 3I Atlas observations. Scientific journals that typically require months of peer review are publishing preliminary analyses within weeks, while conferences that normally plan years in advance organize emergency sessions to address discoveries that reshape entire fields overnight. The academic community has effectively suspended normal procedures to focus collective intelligence on phenomena that demand immediate attention. The collective intelligence mobilization represents unprecedented cooperation between institutions that normally compete for resources and recognition. Universities that guard their research secrets jealously are sharing raw data in real time, while government laboratories that operate under strict security protocols are declassifying information to support international analysis efforts. The collaboration reflects recognition that 3I Atlas presents challenges that exceed the capabilities of any single institution or nation to address independently. The international dimension has created diplomatic complexities that extend far beyond traditional scientific cooperation. When astronomical observations carry potential national security implications, the balance between open research and classified analysis becomes increasingly difficult to maintain. Intelligence agencies that normally operate in complete secrecy find themselves coordinating with academic researchers whose commitment to transparency conflicts with security protocols designed to protect sensitive information from foreign adversaries. The security protocols themselves require constant revision as the nature of potential threats evolves with each new observation. Traditional intelligence gathering focuses on human adversaries whose capabilities and intentions can be assessed through conventional analysis methods. 3I Atlas presents an intelligence assessment challenge that exceeds every analytical framework ever developed, forcing security professionals to develop entirely new approaches for evaluating entities whose motivations and capabilities remain fundamentally unknowable. The unknowable aspects of this encounter have created philosophical challenges that extend beyond practical considerations of defense and diplomacy into fundamental questions about knowledge and certainty. How does human civilization prepare for contact with intelligence that operates according to principles we cannot comprehend, using methods we cannot detect for purposes we cannot assess? The epistemological crisis goes to the heart of how we understand our place in a universe that clearly contains phenomena beyond our current ability to explain or predict. The prediction problem has become particularly acute as researchers attempt to model what might occur during the hidden solar conjunction period. Computer simulations that incorporate every known physical law still cannot account for 3I Atlas's observed behavior patterns, making it impossible to forecast what the object might accomplish during 6 weeks of unobserved activity. The uncertainty creates planning challenges that affect everything from telescope scheduling to emergency preparedness protocols. The emergency preparedness question has forced civilian authorities to develop response plans for scenarios that have no historical precedent. How do you prepare the public for revelations that could fundamentally alter their understanding of humanity's place in the universe? The psychological impact of confirmed contact with superior intelligence could trigger social disruptions that exceed the capabilities of existing emergency management systems to address effectively. The psychological preparation has become a priority for mental health professionals who recognize that the implications of 3I Atlas extend far beyond scientific curiosity into existential questions that challenge basic assumptions about human significance and cosmic loneliness. Support systems are being developed for individuals who struggle to process evidence that our species exists within a galactic environment populated by intelligence that exceeds our capabilities by margins we cannot calculate. The calculation problem reflects deeper issues about human cognitive limitations when confronting phenomena that operate on scales of space and time that evolution never prepared us to comprehend. Our brains develop to handle challenges within terrestrial environments over timescales measured in decades rather than geological epochs. The attempt to understand objects that have been wandering through interstellar space for billions of years pushes human cognition beyond its natural operational parameters. The operational parameters question has attracted attention from cognitive scientists studying how human minds adapt when confronted with information that exceeds their normal processing capabilities. The 3I Atlas encounter provides a natural experiment in how intelligence responds to phenomena that challenge fundamental assumptions about reality and causation. The results could inform everything from educational psychology to the design of human-computer interfaces that help people process information beyond their natural cognitive limits. The cognitive limits issue has practical implications for how scientific institutions organize research efforts that require processing vast amounts of data about phenomena that don't conform to established patterns. Traditional research methodologies assume that natural phenomena operate according to discoverable principles that can be understood through systematic observation and analysis. When observations consistently violate theoretical predictions, the research process itself requires modification to accommodate uncertainty levels that exceed normal scientific practice. The scientific practice modifications have accelerated the development of new analytical tools designed specifically for studying phenomena that resist conventional classification. Machine learning algorithms that can detect patterns in data without requiring prior theoretical frameworks are being adapted for astronomical applications, while statistical methods originally developed for analyzing chaotic systems are being applied to orbital mechanics problems that traditional physics cannot solve. The physics problems raised by 3IATLAS behavior extend beyond academic curiosity into practical questions about how the universe actually operates versus how human science assumes it operates. The discrepancies between observation and theory could indicate either fundamental gaps in scientific understanding or the presence of technologies that manipulate natural law through methods that exceed current human knowledge. Both possibilities require responses that go far beyond incremental advances in existing scientific disciplines. The disciplinary boundaries that normally separate different fields of scientific research have become increasingly irrelevant when studying an object that simultaneously challenges assumptions about astronomy, physics, chemistry, and possibly biology. The interdisciplinary approach comprehensive required for 3IATLAS analysis has created new forms of collaboration between researchers whose expertise rarely overlaps under normal circumstances. The integration of diverse scientific perspectives has accelerated discovery while revealing connections between phenomena that were previously thought to be unrelated. The connection discovery process has yielded insights that extend far beyond the immediate questions raised by this particular interstellar visitor. The analytical methods developed for studying 3IATLAS are being applied to other astronomical phenomena that previously defied explanation, while the international cooperation frameworks established for this encounter are being adapted for addressing other global challenges that require coordinated scientific response. The ripple effects of this cosmic encounter are transforming human approaches to scientific research and international cooperation in ways that will persist long after the object disappears back into interstellar space. The transformation timeline has compressed what would normally be decades of gradual change into months of intensive adaptation as institutions scramble to respond to discoveries that reshape entire fields overnight. The acceleration has created both opportunities and stresses that test the limits of how quickly human organizations can adapt to unprecedented circumstances. Some institutions have thrived under the pressure, while others struggle to maintain effectiveness when operating far outside their normal parameters. The institutional stress patterns have revealed strengths and weaknesses in how human society organizes itself for addressing challenges that exceed normal operational capacity. The most successful responses have come from organizations that maintain flexibility and redundancy in their planning, while the greatest difficulties have occurred in rigid hierarchical structures that cannot adapt quickly to changing circumstances. The lessons learned about organizational resilience under extreme stress will influence everything from emergency management to corporate governance long after the immediate crisis has passed. The crisis management aspect of the 3IATLAS encounter has provided unprecedented insights into how human civilization responds to existential challenges that operate on cosmic scales. The success of international cooperation despite political tensions demonstrates remarkable capacity for coordination when survival instincts override competitive impulses. The failure of some institutions to adapt quickly enough reveals vulnerabilities that could prove catastrophic if future encounters occur with less warning or more immediate consequences. The consequence assessment has become increasingly complex as the potential implications of this encounter extend far beyond immediate scientific discovery into long-term changes in how humanity understands its relationship with the cosmos. Whether 3I represents natural phenomena that push the boundaries of current scientific understanding or artificial intelligence that monitors the development of younger civilizations, its passage through our solar system marks a watershed moment that will influence human thinking for generations. The generational impact extends beyond academic institutions into popular culture, religious thought, and political philosophy as society grapples with evidence that challenges anthropocentric worldviews. The knowledge that objects like 3IATLAS regularly traverse our cosmic neighborhood forces reconsideration of assumptions about cosmic loneliness and terrestrial uniqueness that have shaped human thinking since the beginning of recorded history. The psychological adjustment to living in a universe that clearly contains intelligence exceeding human capabilities represents a species-level challenge that affects everyone regardless of their direct involvement in astronomical research. The species-level challenge has prompted discussions about how human civilization might need to evolve to function effectively in a cosmic environment that contains intelligence operating on scales that dwarf terrestrial concerns. The adaptations required could affect everything from educational curricula to legal frameworks as society prepares for a future that might include regular contact with entities whose capabilities and motivations exceed human comprehension. The comprehension challenge has become a central focus for philosophers and educators studying how human minds might adapt to function in contexts that evolution never prepared them to handle. The cognitive tools that served our species well during terrestrial evolution may prove inadequate for meaningful interaction with intelligence that has transcended biological limitations and operates according to principles that exceed our current understanding. The development of enhanced cognitive capabilities might become as crucial for human survival as technological advancement. The survival question has transformed from abstract philosophical speculation into practical considerations that affect resource allocation and strategic planning at the highest levels of government and scientific institutions. The possibility that 3I Atlas represents the first of many encounters with superior intelligence has forced reconsideration of humanity's long-term prospects and the preparations necessary for maintaining autonomy and dignity in a universe where we might represent intellectual infants compared to entities with billions of years of development. The development timeline disparities have created humbling perspectives on human achievement and the significance of terrestrial civilization within cosmic history. Our species' entire technological development has occurred within a time frame that represents less than 1% of 3I Atlas's existence, while our most advanced capabilities pale in comparison to technologies that can manipulate fundamental forces and navigate through interstellar space with precision that exceeds anything human engineering has achieved. The engineering comparison has prompted intensive analysis of what human technology might become, given sufficient time and resources for development. The trajectory of advancement suggested by 3I Atlas capabilities implies possibilities that exceed current human imagination, while also demonstrating that such development is possible within the constraints of physical law as it actually operates rather than as human science currently understands it. The gap between human achievement and cosmic potential provides both inspiration and sobering perspective on how much our species has yet to learn about the universe we inhabit. The learning potential presented by 3I Atlas extends far beyond technological advancement into fundamental questions about consciousness, intelligence, and purpose that operate on cosmic scales. The knowledge embedded in this ancient wanderer could revolutionize human understanding of everything from quantum mechanics to the nature of time itself, while providing perspectives on cosmic evolution that would be impossible to acquire through any other means. The challenge lies in developing the wisdom and humility necessary to receive such knowledge without losing essential aspects of human identity and creativity. The identity preservation challenge has become increasingly urgent as the December encounter approaches and the possibility of more direct contact becomes increasingly plausible. How does human civilization maintain its essential characteristics while adapting to participation in cosmic communities that operate according to principles we're only beginning to glimpse? The balance between growth and preservation requires wisdom that our species is still developing, while the stakes continue to rise with each new revelation about our remarkable cosmic visitor. The visitor designation itself has become increasingly inadequate as evidence accumulates that 3I Atlas might represent something far more significant than a simple tourist passing through our cosmic neighborhood. The systematic precision of its planetary reconnaissance suggests purpose and intelligence that transform this encounter from scientific curiosity into potential first contact with entities whose capabilities exceed every framework humans have developed for understanding intelligence and technology. The first contact implications have moved from science fiction speculation considerations as government into practical planning agencies and international organizations struggle to develop protocols for scenarios that no previous generation ever seriously made during considered possible. The decisions the next few crucial weeks could determine whether humanity enters the cosmic community as a welcomed participant or remains isolated on a single planet, forever wondering what might have been if we had responded more wisely to our first confirmed encounter with intelligence from beyond our solar system. The beyond our solar system perspective has fundamentally altered how many researchers view humanity's place within galactic civilization that has clearly been operating for timescales that exceed our species' entire evolutionary history. The realization that we exist within a cosmic environment populated by intelligence that has achieved mastery over fundamental physical processes forces reconsideration of assumptions about human uniqueness and the likelihood of maintaining independence in a universe where technological transcendence might be the norm rather than the exception. The transcendence question approaches resolution as 3I Atlas prepares for its hidden passage behind the sun, carrying with it secrets that could reshape human understanding of intelligence, technology, and our place within a cosmos that clearly contains wonders beyond our current ability to comprehend. Whether this ancient messenger from the deep past represents opportunity or challenge, its brief visit to our solar system has already transformed how we think about ourselves and our future among the stars. The answers we've been desperately seeking are about to arrive whether we're ready or not. December 19th isn't just another date on the astronomical calendar. It's the moment when 3I Atlas makes its closest approach to Earth at a distance of 268 million kilometers, providing our final opportunity to extract secrets from this ancient wanderer before it disappears forever into the cosmic depths from which it emerged. The preparation for this encounter has reached levels of intensity that border on the obsessive. Every major telescope on Earth has cleared its observation schedule for the crucial 2-week window surrounding the December approach. Space agencies have repositioned satellites and redirected deep space monitoring networks to focus exclusively on this single target. The coordination effort has grown beyond anything attempted in the history of astronomy, with observatories on 6 continents synchronizing their operations to provide continuous coverage as 3I swings past our planet. But here's what makes this December encounter absolutely critical. The geometry of 3IATLAS's trajectory will expose regions of the object that have remained hidden during its inbound journey. As it passes Earth, different faces of the nucleus will become visible to our instruments, potentially revealing asymmetries, surface features, or structural details that could finally resolve the question of whether we're observing natural phenomena or something far more extraordinary. The surface mapping opportunities development of OBSERVE have promptational techniques that push current technology to its absolute limits. Adaptive optic systems originally designed for studying distant galaxies are being reconfigured to resolve features on an object the size of a small city located hundreds of millions of kilometers away. The challenge is equivalent to reading newspaper headlines from across the Atlantic Ocean, while both the observer and the target are moving at tremendous velocities through 3-dimensional space. The technical innovations emerging from these extreme observational requirements have advanced astronomical instrumentation by decades within a matter of months. Image processing algorithms are being developed that can extract meaningful data from signals barely distinguishable from background noise. Spectrographic analysis methods are being refined to detect chemical signatures that exist at the very threshold of detectability. The lessons learned from studying 3IATLAS will revolutionize how astronomers approach challenging observations for generations to come. Yet despite these technological advances, the fundamental questions about 3IATLAS's nature remain frustratingly unanswered. Every measurement that seems to support one interpretation is contradicted by observations that point in completely different directions. The object displays characteristics of both ancient natural phenomena and advanced artificial systems, as if it exists in some impossible middle ground that challenges the very categories we use to understand reality. The categorical confusion has forced researchers to develop entirely new frameworks for classifying objects that don't fit established definitions. Traditional distinctions between natural and artificial, active and passive, intelligent and mechanical become meaningless when applied to something that demonstrates properties from multiple categories simultaneously. The classification problem extends beyond academic terminology into fundamental questions about how we recognize and define intelligence in forms that might bear no resemblance to terrestrial cognition. The intelligence recognition challenge has attracted attention from cognitive scientists and philosophers who study the nature of consciousness and awareness. If 3I Atlas represents intelligence that evolved under conditions radically different from those that shaped human cognition, our methods for detecting and interpreting intelligent behavior might be completely inadequate. We could be observing sophisticated decision-making processes while interpreting them as natural phenomena simply because they operate according to principles we don't recognize. The recognition failure possibility has prompted development of new analytical approaches that search for patterns indicative of intelligence without assuming specific forms or methods. Machine learning algorithms trained to detect anomalies in complex systems are being applied to 3I Atlas data in hopes of identifying signatures of purposeful behavior that human observers might miss. The artificial intelligence systems designed to study potential alien intelligence represent a fascinating recursive loop where human-created minds analyze non-human minds using methods that transcend the limitations of their biological creators. The recursive analysis has yielded surprising insights about the nature of intelligence itself and the assumptions that guide human thinking about consciousness and awareness. The computer systems studying 3I Atlas have identified patterns that suggest organized behavior operating on timescales and spatial scales that exceed human cognitive processing capabilities. The patterns are too complex and persistent to represent random phenomena, yet they don't match any known natural processes that could account for their systematic nature. The systematic nature of these patterns has become increasingly difficult to dismiss as coincidence or misinterpretation. Statistical analysis reveals organizational principles that operate across multiple observable parameters simultaneously, suggesting coordination between different aspects of the object's behavior that would require some form of central control or planning system. The probability that such coordination could emerge from purely natural processes approaches mathematical impossibility. The mathematical impossibility calculations have created their own controversy within the scientific community as researchers debate whether extremely low probability events should be considered impossible or simply unlikely. The distinction matters because it determines whether 3I Atlas forces us to abandon cherished assumptions about natural law or simply challenges us to expand our understanding of what nature can accomplish under extreme conditions. The extreme conditions question has opened new research directions that explore the possibility that 3I Atlas formed or evolved under circumstances that don't exist anywhere in the contemporary universe. If the object originated during epochs when physical conditions were fundamentally different from today, it might embody principles of matter organization and energy manipulation that are no longer possible under current cosmic conditions. The ancient visitor could represent a living fossil of physics that operated under parameters that vanished billions of years ago. The physics fossil hypothesis has attracted attention from cosmologists studying how physical constants and fundamental forces might have evolved throughout cosmic history. Some theories suggest that the apparent constants of nature might actually vary over cosmological timescales, with different epochs characterized by different relationships between matter, energy, space, and time. If 3I Atlas formed when the universe operated according to different physical principles, it could provide direct evidence of how natural law itself has evolved since the Big Bang. The evolving natural law concept has profound implications that extend far beyond astronomy into the foundations of science itself. If the principles we consider fundamental and unchanging actually represent only temporary conditions that characterize our current cosmic epoch, then our understanding of reality is far more limited than we realize. The possibility that 3I Atlas embodies physics from a different era forces reconsideration of whether scientific knowledge represents universal truth or merely local approximations that apply within narrow ranges of space and time. The universal truth question has philosophical implications that challenge the entire enterprise of scientific investigation. If natural law changes over cosmic time, then the principles we discover through terrestrial experimentation might have little relevance to phenomena that originated under different conditions. The reliability of scientific prediction and explanation becomes questionable when applied to objects that might operate according to physical principles that no longer exist. The prediction reliability problem has practical consequences for how we prepare for the December encounter and interpret whatever data it provides. If 3I Atlas operates according to physics that we don't understand because those physics no longer apply in our cosmic epoch, then our attempts to predict its behavior or interpret its properties might be fundamentally misguided. We could be applying the wrong analytical frameworks to phenomena that require conceptual tools we haven't developed because we've never encountered anything that required them. The conceptual tools development has become an urgent priority as researchers recognize that studying 3I Atlas might require intellectual innovations that go far beyond incremental advances in existing scientific disciplines. The object challenges assumptions that are so fundamental to human thinking that we rarely recognize them as assumptions rather than facts. The process of identifying and questioning these hidden assumptions has begun to reveal how much of our worldview depends on experiences that might be unique to our particular cosmic neighborhood and historical epoch. The cosmic neighborhood uniqueness possibility has forced astronomers to reconsider whether the solar system represents a typical stellar environment or an unusual collection of conditions that might be rare throughout the galaxy. If our local cosmic conditions are atypical, then objects like 3I Atlas that formed under more common galactic conditions might seem anomalous to us while representing the norm for most stellar systems. The perspective reversal would mean that Earth-based science has developed within an unusual cosmic bubble that poorly prepares us for understanding the broader galactic environment. The galactic environment question has become increasingly relevant as observations suggest that 3I Atlas might represent the first confirmed example of what could be a large population of similar objects wandering through interstellar space. The enhanced detection methods developed for studying this particular visitor have already identified several additional candidates that might be interstellar objects with unusual characteristics. If such objects are common rather than rare, then our solar system exists within a cosmic ocean populated by wanderers carrying information and possibly intelligence from throughout our galactic neighborhood. The cosmic ocean concept has transformed how many researchers think about interred of future stellar space and the likelihood encounters with phenomena that challenge our understanding of natural law and intelligence. Instead of viewing 3I Atlas as an isolated anomaly, the emerging picture suggests that we might be witnessing the first of many encounters with objects that embody principles of organization and behavior that exceed our current scientific frameworks. The implications for human civilization extend far beyond academic curiosity into practical questions about how we prepare for a future that might include regular contact with entities whose capabilities and motivations remain completely unknown. The unknown motivations question has become increasingly urgent as analysis reveals that 3I Atlas demonstrates what appears to be purposeful behavior that serves goals we cannot identify or understand. The object's systematic approach to surveying major planetary bodies suggests information gathering that could serve either scientific curiosity or strategic assessment. The distinction matters because it determines whether we're observing peaceful exploration or reconnaissance activities that might precede more direct intervention. The intervention possibility has attracted attention from security analysts who find themselves developing threat assessments for capabilities that exceed every defensive framework ever conceived. The technologies demonstrated by 3I Atlas operate on scales and through methods that render traditional military planning irrelevant. How do you defend against intelligence that can manipulate fundamental forces and maintain complex systems across geological timescales? The question has no meaningful answer within current human strategic thinking. The strategic thinking inadequacy has forced military planners to develop entirely new approaches for managing scenarios that exceed every historical precedent. The challenge extends beyond simple technological disadvantage into fundamental questions about how less advanced civilizations might maintain autonomy and dignity when confronted with intelligence that exceeds their capabilities by margins that cannot be calculated. The asymmetry is so complete that traditional concepts of conflict and cooperation might be equally irrelevant. The relevance question has philosophical implications that extend beyond military concerns into fundamental questions about human agency and significance in a universe that clearly contains intelligence far exceeding our current capabilities. If 3I Atlas represents the norm rather than the exception for galactic intelligence, then human civilization might be comparable to isolated tribes encountering industrial civilization for the first time. The analogy is both humbling and potentially terrifying depending on the intentions of the intelligence we're encountering. The analogy limitations reflect the unprecedented nature of our situation and the inadequacy of historical parallels for understanding what might occur when civilizations separated by billions of years of development finally make contact. The differences in capability and perspective might be so vast that meaningful comparison becomes impossible. We could be facing something so alien in its thinking and motivations that our attempts to understand its intentions are doomed to failure regardless of how sophisticated our analytical methods become. The analytical failure possibility has prompted research into how human cognition might need to evolve to function effectively in contexts that evolution never prepared us to handle. The encounter with 3I Atlas is pushing human thinking beyond its natural operational parameters into territory where our standard methods of pattern recognition and causal reasoning might be completely inadequate. The adaptation required could affect the fundamental nature of human consciousness and identity. The consciousness, Rosscientists and evolution question has attracted attention from nude psychologists studying how the human mind responds to information that exceeds its normal processing capabilities. The 3I Atlas encounter is providing unprecedented insights into cognitive limitations that are normally invisible because they're never challenged by circumstances that exceed their operational ranges. The revelations about human mental architecture could be as significant as the discoveries about cosmic phenomena. The mental architecture insights have practical applications for everything from educational design to human-computer interface development as society prepares for a future that might require cognitive capabilities beyond those that natural evolution provided. The enhancement of human intellectual capacity could become as crucial for species survival as technological advancement, especially if future encounters with cosmic intelligence require forms of thinking that transcend current human limitations. The transcendence requirement has become a central theme in discussions about humanity's long-term prospects and the adaptations necessary for meaningful participation in galactic communities that operate according to principles we're only beginning to glimpse. The changes required might be so fundamental that the beings who eventually achieve cosmic citizenship bear little resemblance to contemporary humans, raising questions about continuity of identity across transformations that affect the core of what we consider human nature. The human nature preservation challenge has become increasingly urgent as the December encounter approaches and the possibility of more direct contact with 3I Atlas becomes plausible. The decisions we make about how to respond to this cosmic visitor could determine whether humanity maintains its essential characteristics while adapting to cosmic realities or loses itself in transformations that achieve survival at the cost of everything that makes us distinctively human. The distinctively human qualities question has prompted intense reflection about which aspects of our nature are worth preserving and which might need to be sacrificed for participation in cosmic communities that operate on scales of space and time that dwarf terrestrial concerns. The creativity, curiosity, and resilience that have driven human achievement might be valuable contributions to galactic civilization, while the competitiveness and aggression that served us during terrestrial evolution could be liabilities in contexts that require cooperation across interstellar distances. The cooperation requirement has become apparent as researchers recognize that the challenges presented by 3I Atlas exceed the capabilities of any single nation or institution to address effectively. The international collaboration that has emerged in response to this cosmic encounter demonstrates humanity's capacity for unity when faced with challenges that transcend terrestrial boundaries. The success of this cooperation could serve as a template for addressing future cosmic encounters and other global challenges that require coordinated response. The coordination success has revealed both strengths and limitations in humanity's capacity for collective action when confronted with unprecedented challenges. The scientific community has demonstrated remarkable flexibility and cooperation, while political and military institutions have struggled to adapt their protocols to scenarios that exceed every framework they were designed to handle. The mixed results suggest that some aspects of human civilization are better prepared for cosmic contact than others. The preparation disparity has created vulnerabilities that could prove problematic if future encounters occur with less warning or more immediate consequences than the current situation provides. The lessons learned from managing the 3 IATLAS encounter are being used to develop better protocols for international cooperation and crisis response. But the fundamental challenge remains: how does human civilization prepare for contact with intelligence whose capabilities and motivations exceed our ability to comprehend or predict? The prediction challenge has become the central focus of analysis as December 19th approaches and our final opportunity to study 3 IATLAS draws near. Every observation, every measurement, every theoretical advance brings us closer to understanding this remarkable visitor while simultaneously revealing new mysteries that challenge our assumptions about reality itself. The ancient wanderer has taught us that the universe contains wonders we never imagined and intelligence that operates according to principles we're only beginning to discover. The discovery process has transformed from routine astronomical observation into a journey that challenges the foundations of human knowledge and forces reconsideration of our place within cosmic history. Whether 3I Atlas represents natural phenomena that push the boundaries of physics or artificial intelligence that monitors the development of younger civilizations, its passage through our solar system marks a watershed moment that will influence human thinking for generations to come. The generational influence extends beyond academic institutions into popular consciousness and cultural evolution, as humanity grapples with evidence that we exist within a galactic environment populated by intelligence that exceeds our capabilities by margins we cannot calculate. The psychological adjustment to living in such a universe represents a species-level challenge that affects everyone regardless of their direct involvement in astronomical research or cosmic speculation. The species challenge has prompted discussions about how human civilization might need to evolve to function effectively in a cosmos where objects like 3IATLAS represent the norm rather than the exception. The adaptations required could affect everything from educational systems to philosophical frameworks as society prepares for a future that might include regular contact with entities whose nature and purposes remain fundamentally mysterious despite months of intensive study. The mystery persistence has become one of the most frustrating and fascinating aspects of the entire 3IATLAS encounter. Despite unprecedented international cooperation, technological innovation, and analytical sophistication, this ancient visitor continues to defy explanation and resist classification according to any framework we've developed for understanding cosmic phenomena. The object exists in a category of its own, challenging us to expand our conceptual vocabulary and develop new ways of thinking about intelligence, technology, and natural law. The conceptual expansion requirement has forced rapid evolution in scientific thinking and methodology as researchers struggle to develop analytical tools adequate for studying phenomena that exceed every existing theoretical framework. The intellectual innovations emerging from 3IATLAS research will influence scientific investigation for decades to come, while the international cooperation protocols developed for this encounter could serve as templates for addressing future cosmic discoveries that require coordinated global response. The global response model has demonstrated both the potential and the limitations of human cooperation when faced with challenges that transcend national boundaries and cultural divisions. The success of international scientific collaboration contrasts sharply with the difficulties of coordinating political and military responses to scenarios that exceed every established protocol. The mixed results provide valuable insights into which aspects of human civilization are prepared for cosmic contact and which require fundamental reformation. The reformation requirements have become increasingly apparent as analysis reveals the extent to which human institutions, thinking patterns, and social structures are adapted for terrestrial rather than cosmic contexts. The encounter with 3IATLAS has forced recognition that our species developed within a cosmic bubble that poorly prepared us for interaction with intelligence that operates on galactic scales and geological timescales. The adaptations necessary for meaningful cosmic citizenship could be as fundamental as the transition from hunter-gatherer to agricultural civilization. The civilization transition analogy has limitations because previous human transitions occurred within terrestrial contexts where the basic parameters of existence remained constant. The encounter with cosmic intelligence might require adaptations that affect the fundamental nature of human consciousness and identity, rather than simply changing how we organize society or develop technology. The transformation could be so complete that the beings who achieve cosmic citizenship bear little resemblance to contemporary humanity. The resemblance question has become central to discussions about preservation versus adaptation as humanity confronts the possibility that survival in a cosmic context might require changes that fundamentally alter what we consider human nature. The balance between maintaining essential human characteristics and adapting to cosmic realities represents one of the most profound challenges our species has ever faced. The profound challenge approaches resolution as 3I Atlas prepares for its closest approach to Earth, carrying with it secrets that could reshape human understanding of intelligence, consciousness, and our place within a universe that clearly contains wonders beyond our current ability to comprehend. The ancient messenger has already transformed how we think about cosmic loneliness and terrestrial uniqueness, while raising questions about humanity's readiness for participation in galactic communities that have been operating for billions of years beyond our entire evolutionary history. The evolutionary history perspective has provided humbling insights into human significance within cosmic timescales that dwarf terrestrial concerns. Our species' entire technological development represents less than 1% of 3I Atlas's existence, while our most advanced achievements pale in comparison to capabilities that can manipulate fundamental forces and navigate through interstellar space with precision that exceeds anything human engineering has accomplished. The accomplishment comparison has motivated intensive research into what human technology and consciousness might become given sufficient time and resources for development. The trajectory suggested by 3I Atlas capabilities implies possibilities that exceed current human imagination, while demonstrating that such advancement is achievable within the constraints of physical law, as it actually operates rather than as we currently understand it. The understanding gap between human science and cosmic reality has become apparent through every aspect of the 3I Atlas encounter. Our theoretical frameworks consistently fail to predict the object's behavior, while our observational capabilities provide data that contradicts established principles of astronomy and physics. The discrepancies force recognition that human knowledge represents local approximations that might have little relevance to phenomena that operate according to principles we haven't discovered. The discovery potential embedded within this ancient visitor extends far beyond technological advancement into fundamental questions about the nature of existence itself. The knowledge carried by 3I Atlas could revolutionize human understanding of consciousness, intelligence, time, and causation, while providing perspectives on cosmic evolution that would be impossible to acquire through any other means. The acquisition opportunity approaches its climax as December 19th draws near, and our final chance to extract secrets from this remarkable cosmic messenger arrives. The decisions we make during these crucial weeks could determine whether humanity enters the next phase of its development with wisdom adequate for cosmic citizenship, or remains forever isolated on a single planet, wondering what might have been discovered if we had possessed the courage and wisdom necessary to embrace the transformative encounter that 3I Atlas represents. The transformative potential of this encounter has already begun reshaping human civilization in ways that will persist long after the object disappears back into the cosmic depths from which it emerged. Whether we prove worthy of the knowledge and opportunities it offers depends entirely on choices we make in the coming days, as this ancient wanderer completes its billion-year journey through our solar system and offers humanity its first glimpse of what intelligence becomes when given cosmic time and space to evolve beyond every limitation we currently consider fundamental to existence itself. So here we are, standing at the threshold of the most significant moment in human history. 3I Atlas has taken us on a journey that's challenged everything we thought we knew about our place in the universe. From its impossible trajectory that suggests intelligence beyond our comprehension, to its chemical composition that defies every model of comet formation, to its gravitational anomalies that break the laws of physics as we understand them. This ancient wanderer has forced us to confront the possibility that we're not alone, that we never were alone, and that intelligence far exceeding our own has been operating in our cosmic neighborhood for billions of years. The December encounter will determine whether humanity takes its first steps toward cosmic citizenship or remains forever isolated, wondering what secrets disappeared with this remarkable visitor. Every observation we've made points to the same inescapable conclusion. 3 IATLAS represents something unprecedented in human experience, something that transcends our categories of natural and artificial, ancient and advanced, visitor and intelligence. Whether this billion-year-old messenger carries knowledge that could revolutionize human civilization or represents reconnaissance by entities whose motivations we cannot fathom, one thing is certain. The universe has revealed itself to be far stranger, far more populated and far more wondrous than we ever dared imagine, and we'll never look at the night sky the same way again. The monster heading for Earth next week isn't coming to destroy us. It's coming to show us what's possible when intelligence is given cosmic time and space to evolve. The question isn't whether we're ready for what 3 IATLAS might reveal. The question is whether we're brave enough to accept that everything we thought we knew about reality was just the beginning of a much larger story.